Okay guys, we are doing our first video here. Hopefully this works well. Please forgive any noise in the background. I got dogs, I got Roomba running, I got my husband on the phone. It's a little crazy, like I'm sure you are too. Alright, so the first section we're doing here is 6.5, and it's called dividing monomials. Divide monomials. So if you remember, a monomial is an expression that has a single term. So we have no pluses and no minuses. So what happens when we want to divide them? Last section, if you remember, we actually multiplied monomials. And just as a quick review, if we had some a raised to the base times another a, if we had some base a raised to the m power times some other base a to the nth power, the rule was that we would add those two. That would be a raised to the m plus n. All right, we also could say that if we had some a raised to the m power raised to the nth power, so notice that the difference here is that we're raising the a, the entire quantity of a to the m power raised to the nth. Here we would multiply them. That's a raised to the m times n. And also, if we had two terms inside here, not two terms, but we had, a coefficient and a variable, or two variables or something like that, raised to the mth power, sounds odd, this would be the equivalent of a to the m and b to the m. So you kind of distribute that exponent there. Notice there are no pluses in there. No pluses in here. That changes everything. Okay, so we have an equivalent property when we, let me change colors here, let's try green, when we are dividing. So let's just say we have some a raised to the mth power divided by a raised to the nth power. So just like up here, when we multiplied and those bases were the same, we added them. Well, the inverse property of multiplication is division. So the inverse property of addition is subtraction. So we're going to subtract those exponents. Pretty easy. So I always like to show an example and a quick explanation why. I told you I like to understand what's going on, and I think that helps to, I'll just go with black, helps to explain why the property is what it is. So let's just say we had x to the fifth divided by x to the third. My bases are the same, they're both x's. My exponents, that's my m and that's my n. So the rule says I just have to subtract them. So that would be x to the 5 minus 3, which is x to the second, or x squared. Well, let's do a quick explanation as to why that is what it is. Let's say I wanted to write this out. Please don't do this for every problem. It just gives you an idea as to why the rule is what it is. X to the fifth would be x times x times x times x times x. There's 5 of them, right? 1, 2, 3, 4, 5. Divided by x to the third is x times x times x. There's 3 of them. So you know that anything over itself cancels out. X over x is 1. X over x is 1. X over x is 1. So those all cancel out. Notice that all I'm left with is 2 x's on top. And we know that x times x is x squared. I should have changed that to black, but that's okay. So that is why the rule is to subtract those exponents. Alright, so we need to try a couple examples. I guess I'll go to black here. So let's just say we had x to the 22nd divided by x to the 18th. Clearly, I don't want to write out 22 x's. That's why the property is so important. So since my bases are the same, all I have to do is subtract my exponents, right? That's x to the 22 minus 18 is 4. X to the 4th. It's that easy. Oops. Oh, I was trying to move down. There we go. All right. What if we reversed it? What if we had x to the 18 divided by x to the 22nd? Property still holds true, even though we have more on bottom than we do on top. We're still going to subtract. So that would be x raised to the 18 minus 22 is now negative 4. So x to the negative 4. If you remember, I'm pretty sure we've talked about this before. Negative exponents, hold on, exponents, there we go, sorry. That means that we're going, that in algebra, that means that we can put it over 1, no, put it under 1, sorry, and make it a positive. I'm pretty sure we talked about that before. All right, let's do another example. How about we do one with a number instead of a variable? Let's say we had 13 to the 4th power divided by 13 squared. How about that one? So, you know, the rule says if our bases are the same, our bases are both 13, our exponents are 4 and 2. The rule says we can subtract them. So that would be 13 raised to the 4 minus 2 is 2 squared. We could leave it like that, or we could expand it. 13 squared is 169. All right. So also we do have, you know, it's possible to end up with a 0 exponent. Totally legit. What if we had 13 to the 4th divided by 13 to the 4th? Oops, Fox News popping up. All right, so we know that the rule says that we can subtract them. So 4 minus 4 is 0. So that means the rule says this is 13 to the 0 power. And if you remember, you can always check it on your calculator, anything to the 0 power is 1. And this makes sense because 13 to the 4th is numerically the very same thing as 13 to the 4th. I don't know what it is. I'd have to pull out my calculator and check it. But when you have anything divided by itself, you have 1. So this is a good explanation as to why anything to the 0 power is 1. All right, so that was the first rule that we talked about. Or, sorry, that's the only one I've given you. Let's see if there's anything. Oh, we also have some fractional types. So this would be another rule. Let me give it to you in red. So if we have it's called the quotient property. So let's just say we have sum A, base A, divided by base B, and we're going to raise both of those. Sorry, the other one was the quotient property. This is the quotient to a power property. So we have A divided by B raised to the m power. So in the same way, whoops, there we go. In the same way that we distributed that when A and B were multiplied by each other, we're still going to distribute that. So that will give me A to the m divided by B to the m. Doesn't matter that A and B are not the same property. They still both get that m power. You got to note that B cannot be 0 because anything divided by 0 is undefined. All right, so let's do a quick example using a couple of these. I'm going to switch colors. I'll go back to black for my examples. So let's say we have y to the 4th squared divided by y to the 6th. So note that we got to simplify this guy up here first before we can move on. So let's simplify the numerator. So that's actually from the last section. So we have a term with an exponent raised to an exponent. Remember, we multiply those. That gives me y to the 8th. 4 times 2 is 8. Divided by y to the 6th. Now we can use this quotient property. Notice that my bases are the same. They're both y's. They both have exponents, so we subtract them. 8 minus 6 is 2, so this leaves me with y squared. Okay, let's try another one. Looking for something else. How about this one here? Let's actually use this one a little more here. So let's say we have y to the 9th divided by y to the 4th squared. Now this is the property. It just so happens to be that a and b are the same thing. So note that the order of operations would say we do whatever inside the parentheses first. So let's do whatever is inside the parentheses first. So if we were to simplify inside, the bases are the same, so we just subtract our exponents. So that gives me y, 9 minus 4 is 5. But notice it is squared. We haven't done anything with that squared yet. If we were to apply the property from last rule, the multiplication or the exponent property, we would have to multiply those guys. So that would be y to the 10th. All right, let's try one where our bases are not the same. So next example, let's say we had a squared divided by b cubed to the 4th. I used a and b, but you know that those can be any variables we want them to be. Okay, so our bases are not the same. So we can't do what we did up here. Up here we tried to simplify inside parentheses. We didn't try, we did simplify inside the parentheses first. We can't do that because there is no simplification. But we can use the property where we distribute inside. So that will give me a, 2 times 4 is 8, divided by 3 times 4 is 12, so that'd be b to the 12th. And we can't do anything further with this guy because he does not have the same base. Let's try an example with numerical coefficients. Let's say we had 3x to the 4th divided by 7y squared. All right, so again, we have our bases are not the same, and we have terms raised to an exponent. So we're going to distribute this. But the thing to notice here is that we need to make sure that not only is the x to the 4th squared, but the 3 is also squared, and the 7 is squared, and the y is squared. Everybody is squared. All right, so that would give me 3. I'm going to write it out, this step. Feel free to skip this if you're really comfortable with this. So 3 squared times x, 4 times 2 is 8, divided by 7 squared, and then y squared. So notice that every single term got a squared because of it was all in parentheses. So let's do a little simplification here. 3 squared is going to be 9. So 9x to the 8th divided by 7 squared is 49, and then y squared. So if my numbers here, my coefficients would simplify any, I would probably simplify those, but they don't. They have no common factors. So I'm going to leave it like that. My bases are not the same, so they don't combine in any way. Let's see what else we might do from this section. Just note that sometimes, I've used a fractional line. You could also use a division line, or WebAssign could, and it's still the same kind of problem. You're going to work it exactly the same. You just have to, let's do an example real quick. Write it as a fraction. Let's say we have 27p to the 4th, q to the 7th, divided by negative 45, p to the 12th, q. So we're dividing this, that really is a monomial because there's no pluses and minuses. This, let me change that to red. This monomial divided by this monomial. So you can rewrite this as a fraction, 27p to the 4th, q to the 7th, divided by negative 45 p squared q. So it's the same problem, just rewritten as a fraction, and now I can apply those rules. We really haven't done one like this, but let's see what happens. So we've got 27, numerically, we have 27 and negative 45. So I'm going to look to see whether or not these have any common factors. 9, I think, is the biggest one that I see. So 27 divided by 9 is 3. Negative 45 divided by 9 is negative 5. So I'm going to put the negative out front here. Notice it doesn't matter where it goes as long as it's, making my term negative, because a positive divided by a negative is a negative. All right, so now I can simplify. Let's combine our like terms. These are p's. They're both p's. So using that quotient property, since their bases are the same, 4 minus 2 is 2. So that would be p squared. And then my q's have common bases. So I have q7 and q, remember that's technically to the first if it's not written. So 7 minus 1 is 6. So that would be q to the 6th. And that's that one right there. You could also write it as one big fraction, but it doesn't matter how you do it. Both are true. All right, we're stopping for this one. So the web assign is posted. So you should do those. If you have any questions, you can always email me. You can post them. Actually, I'll create a little forum. We're going to learn how to use the forum there, and you can post questions there, and I can answer them, or other people can answer them. And hopefully this is going to work.